Hi guys, my name is Miss McCumber and I'm the dance instructor here at Marshall High School. This year's production is called Unstraightened. It's basically a reaction to people going out against social norms and being unstraight in different ways, literally and in society and all of that jazz. So we have musical selections from Area 11 and many different artists. You can look at the program for the rest of it. But anyways, here today we're going to talk about more like the background of what's going on behind the scenes and what I have to do as a dance instructor in order to throw this performance on. So basically, we're going to go through all of that and we're going to look at the calculus with a lot of what we're doing today. Thank you and enjoy. One of the most important things as a dance instructor is to know the finances behind what this production will cost and how much you'll be intended to make and what your overall profit will be. And one way to easily figure out some of this stuff is by looking at attendance and basically when and how people are coming in, what days are the best, what times are the best, etc., etc. And so in order to do this, I decided to research logistical growth. So we'll figure out what happens from there. Alright, so after researching logistical growth, we were able to come up with this formula here. The L in this formula represents the carrying capacity. The A is represented by this equation, L minus Y naught over the initial Y. The K is a constant, and the T is time. From plugging all the information in, we get Y equals 290 over 1 plus 16.13 e to the negative 0.1 t. Graph this. Here's the graph of the equation we just solved for. The yellow represents the highest rate, or the largest slope. In other words, the point at which the derivative is the highest. The circled area in the black is where the amount of people coming starts to level off. In other words, we need more people to provide sales during the middle time because that's when the most amount of people will be coming. That's when we can expect the most amount of audience members. Now we can take the limit of this formula to see if it equals the carrying capacity, and it does in fact. Therefore, it checks. That's a wrap. From there, we can use this data in order to figure out how many people we should have selling tickets at what times. It's better to have more people during the middle times than at the beginning or near the end. So we can have about 3 people in the middle, 1 at the beginning and 1 at the end.
In order to maximize your profit, you would just need to sell the most amount of tickets that you possibly can. And since the theater can hold 290 people, over the course of 3 days, we need to sell 870 tickets, since the cost itself remains stagnant at $600 a day. So what we're going to do is we're going to try to minimize the sale amount of time with having that maximum profit. This is going to be in per days, so the concert occurs on Wednesday through Friday, May 23rd through 25th. So we have our function t of x equals negative 2.876x squared plus 57.52x minus 26.529. This represents the amount of hours that you would need to reach the maximum number of ticket sales in a day. So in order to do this, we need to optimize using a derivative. So you have the derivative of t equals negative 5.752x plus 57.52. Set the derivative equal to 0 and solve for x. You get x equals 10. As a result, there should be 10 hours of available selling time a day. The way we will allocate this 10 hours of time will be some in the morning, some in the middle of the day, and some after school, and some prior to the concert. For our next task here, I called in a guest to help us out with the calculations. So for the performance dance Illusion by VNW Nation, we needed to create these shapes and models of weird curvy structures and all. It's a lyrical dance, and so in order to do that, we have this guest here that I mentioned previously. Alright, so here we have him, the smartest calculus student here at Marshall High School. What's your name, buddy?
Curtis.
Alright, Curtis here came up with some equations that we can use in order to create all these models. Let's take a look. Curtis, will you write down that first equation for us? Alright, show us what you got. Alright, so what's happening here is you're having the area bounded by y equals the square root of x minus 1 and y equals this x minus 1 squared about the x-axis. What kind of figure does this show? Let's see here. Curtis, what's the second one you got here? Alright, show us what you got. So you got the volume bounded by y equals to the square root of x to the 3 halves plus x sine x squared and y equals the square root of x squared plus x sine x squared about the x-axis. Man, that seems like a crazy one. Let's see what we got. Thank you, Curtis, for all the hard math that you did. We appreciate it. Bye! For one song on the performance, we're going to have a swing set up. The person on the swing will be attaching lights, kind of like this. Kind of look like an upside down Christmas tree, more or less. It's going to be the song called All the Lights in the Sky by Area 11. I'll play some of it here soon. However, they're going to be swinging back and forth. The swing itself is 7 feet long, which means that the entire length will be 14 feet at its max. Each time the swing moves back and forth, it travels 90% of the last movement. In other words, the first time it will be released from here, will travel 90%. Released from here, travel another 90%. We need to determine how long of a string of lights we will need in order to light up this entire display until the end. I figured we could use infinite series. And in order to do this, we would have to take the summation of n equals 1 of 9n over 10 times 14. When calculated, it equals 126, which means we would need 126 feet of lighting in order to ensure that we'd have the maximum amount of lighting needed to cover this amount. Alright, so I promised you a sneak peek into some of the dances of our concert, and although the swing was not capable of being here in time, the shipment is still being delayed. I'll show you the different dance. It's Illusion by VNV Nation. This is the performance ensemble's dance. It's a lyrical one. So enjoy, and thank you for watching.
I know it's hard to tell how mixed up you feel, hoping what you need is behind every door. Each time you get hurt, I don't want you to change, 'cause everyone has hopes. You're human after all. The feeling sometimes wishing you were someone else, feeling as though you never belong. This feeling is not sadness, this feeling is not joy. I truly understand. Please don't cry now. Please don't go.
And with that, thank you guys.